Pleasant evening, everyone. My name is Devon. I'm a student at the University of Guyana. I have two quick comments and one question. And my colleague has a question. I'll tie into our last question. So my first comment is, I appreciate that Professor Dirk sort of mentioned that your university plays a role in achieving sustainable goals. That is something we need to adopt. Secondly, it will be interesting to learn the strategies, that your country used to achieve cooperation of those agencies. And finally, the question is for Dr. Rhino. As a student, I would like to know, does the Department of Energy have projects that they can pull students on for their undergrad research or even masters that you can fund to push research? And Patrick will ask part B to that question.
Yes, good evening everyone. Patrick and also a question to Dr. Rhino. I would just like to ask if the Guyana Department of Energy would have opened more internships to say for students in the university. Yes.
Thanks for the two questions. First of all, I think we all can appreciate the department was established on the 1st of August 2018. We are here ramping up for first oil. With regards to providing scholarships, I will direct you to the PSL that is still there, as well as Chevron. In terms of issue with internship, we do have on our Facebook page the possibility of interns working with us. We ask that you supply or submit your application. I think that closes at the end of June, and then we will make a selection therefrom. Thank you.
Malcolm DeFreitas. For anybody who can answer the question, I have been hearing so much about the incompleteness of the battery function, but nobody spoke about flywheel technology for the storage of energy. Maybe someone can start to look at that as a possibility.
We're actually looking at it. Yeah, thanks for that question. Actually, the last speaker mentioned in his summation that storage is more than just lithium-ion battery, which many of us spoke about in the initial set of discussion, the presentations. When you talk about storage, you have chemicals to batteries that are used, you have physical storage systems, and you heard talk about pumped hydro earlier. You also have compressed air storage, you also have the flywheel. Flywheel options are actually being utilized, tested in Jamaica at the moment within the utility as a utility scale system, 1.5 megawatts. We are looking very closely at the performance of that system, and we'll use the experience of that to help to guide how we look at using flywheels in other CARICOM jurisdictions. It's important to understand how the technology works within small grid systems, because it's going to be relevant to how it's deployed in every other system going forward.
Good night, everyone. Cindy Armstrong, Head Department of Economics. I've recently returned from a seminar in Chile, organized by ILO and UNFCCC, and the discussion was based on climate change responses and jobs. Our GSDS happens to be our overarching response to climate change. My question, therefore, is to Dr. Mahender. Have we been able to identify an optimal mix of renewable energy and what impact it will have on jobs, but more so decent work according to the ILO? And I think as Dr. Sharma mentioned, our potential in terms of renewable energy is about 7,000 megawatts. Are we thinking about exporting energy if the discussion has started? Thank you.
With regards to the optimal mix, I think I would let the other experts on the panel deal with that, but I'm quite sure that will depend on your demand. It's not static. And an optimal mix will be futuristic in terms of what kinds of industries you'll be pursuing, what kinds of projected demand you expect, and therefore what will be your ultimate quantum of consumable that you'll be looking towards going forward. In terms of the discussion surrounding possible exportation of energy, it is part of the discussion that we are having at this point in time. And that is why I spoke to the fact that much of what we do, we have to pursue a no regrets measure. So for example, within the ambit of the Great State Development Strategy, we need to re-examine some of the assumptions, some of the projects maybe we're thinking of. Let's take, for example, the connection from Lethem to Georgetown or somewhere along the coast. What would be best for that if we are to continue to pursue a green state ethos? Would it be a road link? Should it be something more like a rail? And along that line, possibly having sufficient lines that you can export power to northern Brazil? Because as we begin to move further into the life of the petroleum fields, more associated gas will become available, which are expected, the volume of gas coming to shore would be expected to exceed the domestic demand. And so there is a possibility therein. So yes, those discussions have begun, but as you know, it will require a lot more with regards to bringing in more parties into the mix. In terms of job displacement, again, everything I think is contextual. You're looking at what base we're starting with in Guyana. You're looking at the fact that we have massive room for industrial expansion. I'm not speaking here about heavy industries. I'm speaking more about the light industries, the service sector. And so I am not concerned at this point that that would be a major problem for Guyana going forward. If anything, I think Guyana needs to be considering in the larger menu of the discussion is a potential immigration influx that Guyana can experience going forward. I'm not saying it's a bad thing, but we need a discussion around that over here.
Thanks, Mark. I just want to address the question of the renewable energy mix and the optimization of the renewable energy mix for Guyana. I want to caveat this with some of what Albert said earlier in his discussion around the new generation. Because at the end of the day, there are some considerations that has to be taken into place in regards to what investments are going to be made in generation and what type of generation is going to be made in the short term. Because if it is that you're investing in power plants and power plants such as diesel power plants or diesel gas power plants that are 20 years in life and maybe will not be paid back for until another 7.5, 8, 9, 10 years, then that will constrain the kind of investments you make in conventional generation is going to constrain how much you can do in regards to renewable energy generation within the mix, because otherwise you will end up with stranded assets that you that you would have ended up paying for twice. If you put in a national generation before that generation would have paid back for itself. So as an example, you put diesel in and you bring in solar that displaces that diesel would not have performed its function and the cost recovery would not have happened. So we are trying to look at the judicious mix in terms of how it is that we would integrate enough renewables into the system based on what is practical and cost effective, based on what is attractive to investors, based on what the grid can accommodate in a very, very defined time scale through our planning process. We are going to be working very closely with the government, that is Ministry of Public Infrastructure, GEA, GPL, and we being CARICOM Secretariat, to model the system, to really identify through the modeling really where the correct opportunities are for the integration of new generation and from what sources will get the most cost effective and also resilient supplies, because we also want to understand that the supplies that we are bringing into the system are going to not necessarily be the most vulnerable to the vagaries of climate change. If we're talking about hydropower as an example, we have to understand that climate and heat change and hydrological change will impact hydro supplies, and we have to see whether or not the amount of hydro will be something that is likely to not be able to support what our requirements are in 5 years, 10 years, whatever it is. We have seen cases like in Belize, for instance, where when hydro supplies drop because of droughts, which are many times climate related, it doubles the cost of energy because you now have to pull from other sources that would have been much more expensive. So the judicious balance is not just about throwing more renewables into the system, but really to understand how you balance the cost-effective and the resilient resources into a flexible and adaptable mix so that you are able to support the demand in a way that is also very flexible and adaptable in itself. Because the demand at the same time is also going to be supplying energy, even as you are going to be supplying energy from the supply side. So you are looking at energy supplies coming both ways. In CARICOM, for instance, by next year, we are going to have a 400 kilowatt system supplying energy potentially to the grid and to the building itself. So there are going to be consumer-produced energy supplies as well as utility-produced energy supplies, and we have to look at how we optimize solar, wind options, hydro options from small hydro options, along with the gas and potential options therefrom, along with the diesel and fuel oil options, into one mix that gives us all of those criteria, complex criteria, that must be sufficiently satisfied at the same time.
Thank you very much, and thanks to the presenters. Two aspects I want to raise questions on, and I was happy that Mark touched on one. Energy for Guyana. He represents people, and there are two aspects of this thing. Expectations, one side, and frustration on the other side. Frustration. The reality is that Guyana today is speaking of energy for Guyana to come. And I'm always concerned about the young people and their inclinations. The question, though not seemingly related to energy, it's about energy. That energy of expectation. And the point is that how do we address that in terms of our own systematic planning? When schemes are built, when roads are built, when agricultural development is taking place, I'm asking, is that all factored into the plans when we speak to the point of energy? Because the rising expectations can lead to rising frustrations.
I will speak to that quickly because I guess I was the one speaking about energy planning. We usually do projections and forecasts as part of the planning process. So we will do economic forecasts based on the growth rate and different surveys that will factor in new construction, new industries, and nowadays, in the case of the integrated resource and resilience planning process that we are introducing for the first time in the region, we're also factoring loss inefficiency from temperature-sensitive generators, so that we can include that too in the planning process, and also looking at drops in efficiencies from cooling and refrigeration, as well as increased demand for cooling and refrigeration on the supply side. So we are factoring climate issues, economic growth issues, social advancements that will also lead to man wanting 2 and 3 TVs where they had none previously into the planning process. I mean, we may not be able to get it right, but we are using a number of projections based on what we get from the different sectors to make those projections. And when we do that, we will use that as a basis to look at the forecast 5 years, 10 years, 15 years from now, looking at different scenarios for each forecast, not just one scenario, but multiple scenarios. And in fact, sometimes the scenario that's accepted may not be the scenario that is cheapest, but maybe the scenario which gives us the most flexibility so that we can adjust quickly if it is that we recognize that we're off with some of our assumptions. And while it is that we plan 5, 10, 15-year horizons, we usually have revisions periodically. So we have 1 year, 2 year revisions. And with respect to the operation, there are even daily plans and hourly plans. and we are looking at even bringing in forecasting that allows the utility at the hourly basis to forecast based on projections of cloud cover and projected drop in solar PV, how to dispatch to account to really shore up for any loss that would result from any variability in the daily resources from solar, wind, etc., because that's going to be important.
Okay, we will have the voting times. Our student from the Faculty of Earth and Environmental Sciences.
Good evening. The university wishes to extend sincere thanks to its partners for this event: Trent University, CBMEX, Arizona State University, Guyana Energy Agency, the Department of Energy, and CGX Energy. We also wish to extend thanks to the Acting Vice-Chancellor, Professor Michael Stahl, and the panelists and the speakers who contributed to this evening's discussion: Dr. Mahender Sharma, Dr. Devon Gardner, Ms. Renewable Klass, Dr. Mark Leno, Mr. Vishal Prasad, Professor Safaye Kawai, Professor Jose and Professor Rivers, and also Mr. Albert. And we'd also like to extend a special thanks to the several people who consistently partner with the university to make this series a success. This includes the staff of the Texas Hotel, the Deputy Vice-Chancellor of PACE, Professor Paloma Mohamed, and her team, comprised of Ms. Afisha Zran, Ms. Trevon Aziz, Mr. Ronald Himes, Ms. Christine Chauvier, Ms. Tara Smith, Ms. Marlene Gopal, and the intern, Chanel Gibson. The personnel officer, Mr. Jeffrey Walcott, the local media corps, and Mr. Neil Suklal, and the staff of the Impressions Lab. We are also very grateful for the work of those members of the university community who serve as ushers, and to you, the member of the civil society who came and participated here and contributed. So again, thank you for your presence. And remember to go to Catholic friends and to network and learn from each other while we're here. So good night.